Angelman Syndrome Genotypes, sponsored by the Foundation for Angelman Syndrome Therapeutics. Everyone inherits their chromosomes from their parents. The chromosomes carry genes, which are coding instructions for making proteins. An important example of this is the UBE3A protein, which is made from the UBE3A gene located on chromosome 15. People living with Angelman syndrome, or AS for short, do not have enough functional UBE3A protein in their brains. Typically, each person has 2 copies of the UBE3A gene, one from each parent. The one from the father is called paternal, and the one from the mother is called maternal. In all people, the paternal UBE3A gene is silenced or turned off in brain cells, a process called imprinting, so the maternal UBE3A gene is responsible for making all the UBE3A protein in the brain. Now, changes to the maternal UBE3A gene can result in less or no UBE3A protein in the brain, or the UBE3A protein that is produced may not work properly. These genetic changes are grouped by type and are called genotypes. There are 5 main genotypes that cause AS. Knowing the genotype of each person living with AS is important. Although each individual living with AS is unique, people with the same genotype may have certain behaviors or characteristics in common. Another reason for identifying the genotype is that some genotypes have a higher chance of running in families. Doctors and genetic counselors can use this information to determine the chance of other family members inheriting AS. Finally, genotype is often a criteria for participating in research. So knowing the genotype is a key element in determining eligibility for clinical studies investigating potential AS therapies. The most common genotype that causes AS is called deletion AS, or deletion-positive AS. It occurs in about 70% of people living with AS. People living with deletion AS are missing the maternal UBE3A gene, and because the paternal UBE3A gene is turned off, the UBE3A protein is not produced at all in the brain. In addition, several genes that sit next to the maternal UBE3A gene are also deleted. These other missing genes may contribute to AS features, such as communication difficulties and seizures, resulting in more severe symptoms in deletion AS as compared to individuals with other AS genotypes. Deletion AS can be categorized based on the length of the deleted segment, and exactly which genes a person is missing depends upon how long the deleted segment is and where the deletion starts and ends. In most individuals, the deletion of UBE3A and the surrounding genes is a random event and not inherited from a parent. This deletion can occur in only one egg when the mother's eggs were developing, which happens before the mother is even born. When this happens, the genotype is not passed on to future family members. In rare cases, deletion of UBE3A may occur in more than one egg or may be due to a chromosomal rearrangement, which can increase the chance that additional children will have deletion AS. Mutation AS occurs in about 10% of people living with AS. In this genotype, a coding change, also called a mutation or variant within the UBE3A gene, causes a change in function of UBE3A protein, making it inactive or less active. Mutations can occur anywhere in the gene and are categorized based on how they affect the gene and the protein. Most UBE3A mutations result in no UBE3A protein, but some may allow for some protein to be made, although that protein is likely less functional or may be completely non-functional. Individuals with some functional UBE3A protein may have fewer or less severe AS symptoms. Unlike the other AS types, which use DNA methylation testing for diagnosis, mutation AS is diagnosed by sequencing, which is a test that reads genetic code. Mutation AS may be inherited from the mother who has the same mutation, or it can be a brand new change in the egg, also called de novo, that made the person living with AS. If the mother has the mutation, each future pregnancy has a 50% chance of inheriting mutation AS. Uniparental disomy, or UPD for short, occurs in about 5% of people living with AS. Individuals with this genotype have 2 copies of paternal chromosome 15 and no maternal chromosome 15. Since both paternal copies of the UBE3A gene are turned off in the brain and there is no maternal UBE3A gene, individuals living with UPDAS have no active UBE3A protein in the brain. In addition, individuals living with UPDAS make extra proteins from several other genes that sit next to UBE3A and are turned on in both the paternal chromosome 15. These extra proteins may lead to a lower risk of seizures and higher risk of obesity in individuals living with UPDAS as compared to individuals living with deletion or mutation AS. Usually, UPDAS genotype is a sporadic event that only occurred during the development of the sperm or egg, and other family members do not have an increased chance of inheriting AS. Rarely, parents can have a chromosome rearrangement in their cells that increases the likelihood that additional children will have UPDAS. Imprinting center defect, or ICD for short, occurs in about 3% of people living with AS. Normally, the imprinting center's job is to control and reset imprinted genes, like the UBE3A gene. However, when there is a defect in the imprinting center, the UBE3A gene may be incorrectly turned off in the brain, even though the UBE3A gene was inherited from the mother and is supposed to remain on and active. ICD can be caused by either a deletion of the imprinting center, called ICD deletion AS, or an error that affects the function of the imprinting center, called ICD non-deletion AS. In ICD non-deletion AS, the imprinting center does not have any detectable sequence differences, but is still not functioning correctly, resulting in the maternal UBE3A gene being turned off when it should be on. ICD deletion AS can be inherited from the mother if the mother also has that same deletion, and any future pregnancies will have a 50% chance of having ICD deletion AS. It may also be a de novo, or new random event that occurred during the formation of only one egg in the mother. On the other hand, ICD non-deletion AS is believed to happen randomly, often after conception, and is not typically inherited. Mosaic, the rarest AS genotype, occurs in about 1% of people living with AS. In the Mosaic genotype, some cells contain a functional UBE3A gene and some cells do not, resulting in normal UBE3A protein in some cells and no UBE3A protein in others. All individuals living with Mosaic AS have a primary underlying genetic difference, such as ICD, UPD, mutation, or deletion. The most common genetic change with this genotype is ICD, or imprinting center defect, caused by an error in the imprinting center. Individuals living with Mosaic AS may have different degrees of mosaicism. In some individuals, the majority of cells may make UBE3A protein, while in others, the majority of cells do not make UBE3A protein. Individuals who make some UBE3A protein are likely to have milder symptoms, such as fewer seizures, than those who do not make any protein. Mosaicism often occurs after conception, is not typically inherited, and the chance of it occurring in future pregnancies is usually low. For more information about Angelman syndrome and its genotypes, visit the Foundation for Angelman Syndrome Therapeutics, also called FAST, at cureangelman.org. For specific questions, reach out to FAST's genetic counselor.